So did you all write it down? Did you write down the sequence? Did you write down the sequence? So this is the sequence generated. Okay, the sequence generated is corresponding to x by 1 plus x. The sequence generated is 0, 1, minus 1, plus 1, etc. So you will be given this question and you will be asked to generate the sequence. Finally, as an answer, you have to write the sequence. So let us move on to the next question. So the previous question was x by 1 plus x. So the next question is 3x by 1 plus x the whole square. Next question is fourth question, 3x by 1 plus x the whole square. This is the generating function given. This is g of x. You have to, from g of x, you have to find out the sequence. Okay, the question is to find out the sequence given g of x. So again, here also, what is the method that we are going to use? The same thing that we had done before can be applied here also. That is, you know what is 1 by 1 minus x, isn't it? 1 by 1 minus x is equal to, what is 1 by 1 minus x? Or you can study 1 of 1 by 1 minus x the whole square. I think we had done that also. That is 1 plus 2x plus 3x square plus 4x cube plus etc. That is corresponding to the sequence 1, 2, 3, 4, etc. The function is, generating function is 1 by 1 minus x the whole square. Okay, so since the whole square comes here, you have to choose a sequence that is familiar to you. So 1 by 1 minus x the whole square corresponds to this particular sequence. So the nearest sequence which you are familiar with should be applied. If you take 1 by 1 minus x, then the square, you won't be able to get this.
Screen.
Okay. I didn't share the screen. Sorry, I didn't share the screen. Okay, I'll share it now. Is it visible? Is it visible? Is it visible to you? Okay, Akshara, okay. So this is the question, fourth question, 3x by 1 plus x the whole square. Okay, this is the generating function given to us and we have to find out what the sequence is. So looking at this form of the generating function, that is 1 by 3x by 1 plus x the whole square, we know a familiar sequence 1 by 1 minus x the whole square. It corresponds to the sequence 1, 2, 3, 4, etc. So this you should learn by heart. Okay. So 1 by 1 minus x the whole square is corresponds to the sequence 1, 2, 3, 4. So you can just write that sequence here. That is 1 by 1 minus x the whole square is equal to 1 plus 2x plus 3x square plus 4x cube is the polynomial corresponding to this generating function. So what we need here is 1 plus x. So what we have to do is, what should we do? To get 1 plus x there, you substitute x by minus x. So minus of minus x, it becomes plus x. So you substitute x by minus x on both LHS and RHS of this equation. You get 1, x is substituted by minus x. So this becomes minus 2x. Then minus x the whole square is x square itself. So this becomes 3x square. And here, with all the odd powers, it turns out to be minus. Okay, 4x cube plus etc. So I had obtained the denominator part of the given generating function, that is 1 by 1 plus x the whole square. Now just multiply by 3x, isn't it? You will get the answer, isn't it? So you multiply this by 3x, you get 3x by 1 plus x the whole square is equal to both LHS and RHS you have to multiply. So 3x minus, what will this term becomes? Minus 2x into 3x minus 6x square, then plus 9x cube, then again minus 4x cube into 3x minus 4 into 3, 12 x raised to 4 plus etc. Okay, so this is what we want, isn't it? This is the question given to you. Now I had reached a particular, I had generated a particular polynomial. Now what is the sequence that I can conclude from this polynomial? What is the sequence generated by this polynomial? Can you write the sequence? What is the sequence generated? You should start from x raised to 0, isn't it? For the generating function, the power always starts from x raised to 0, then x raised to 1, x raised to 2, x raised to 3, and so on. So here, x raised to 0 term is not there. So the first term is a0 is 0. Then x raised to 1. So a1 is the coefficient of x raised to 1, so you get 3. Then a2 is the coefficient of x raised to 2, you get minus 6. Then 9 minus 12 and so on. This is the sequence. So the sequence corresponding to the given question is 0, 3, minus 6, 9, minus 12, etc. Is it clear? So whenever you're given a question, you have to just look at it and find out if you have any sequence which you studied is familiar to this. So if it is powers, if there is a square term down, then you just look for, just study this by heart and then apply it. That is 1 by 1 minus 6 the whole square is the generating function corresponding to 1, 2, 3, 4, etc. So write this polynomial, expand that the generating function, and then you modify it to reach the question. That is, you need plus x here, so substitute x by minus x. So minus of minus x becomes plus x, so you get the denominator part. So you substitute x by minus x on both LHS and RHS, the sequence changes like this. And then on numerator part you have 3x, so multiply both RHS and LHS by 3x, you get the polynomial in this form. And here we have powers, look at the powers of x and write down the sequence. So if the x raised to 0 term is not there, then the first term is 0, a0 is 0. Then a1 is the coefficient of x raised to 1, write that. Then a2 is the coefficient of x raised to 2. So this is minus 6. Since the polynomial is of the form a0 plus a1x plus a2x square, etc. If minus comes here, then it is plus minus 6x square. Okay, this is of this form. So the coefficient is minus 6. Is it clear? Is it clear to you? Okay. So this is one form of the question, that is, given the generating function, you have to identify this sequence. So initially we had you are given sequences and you had written the generating function, and the second form of the question is just the reverse, that is, given the generating function, you have to find out the sequence. So these questions, you should go through all these questions. Series exam, most of the questions are covered in series exam, so you have to go through all these questions. Okay, is it clear? Did you hear what I said? So let us move on to the next question, next section, that is exponential generating function. So write the heading. So before that, let me tell you the sequences which you should by heart. Okay. This is module 4 notes. See, this is just an introduction because here generating functions they are used to solve enumeration problems. Starting from the definition, this is what we were speaking of in the last few days. That is the coefficients a0, a1, etc. Then the general form of the generating function is a0 plus a1, etc. These are the theory part. Okay, you have to read through all this. And here I had given this we will come to next. The basic generating functions. So in the notes, I had given some basic generating functions which you should by heart. Okay. So the first one is 1 by 1 minus x corresponding to the sequence 1, 1, 1, etc. This we were using for using it many times in the formulas. So the basic generating function, this is for the sequence 1, 1, 1, etc. The generating function is 1 by 1 minus x. Okay, you should study that. For the sequence 1, 1, 1, infinite sequence 1, 1, the generating function is 1 by 1 minus x. You can generalize it in the sigma form, that's is equal to 0 to infinity. This is an infinite polynomial or an infinite sequence, so it is sum of the powers, that is x raised to 0 plus x raised to 1, etc. So next sequence that you should study is 1 by 1 plus x. It is the generating function for this sequence, that is 1 minus 1 plus 1 minus 1, etc. The infinite sequence. So whenever you want to solve certain problems, if you get such a sequence, then you can substitute it by the generating function 1 by 1 plus x. Okay, so the second formula that you should study is 1 by 1 plus x is the generating function for 1 minus 1 plus 1, etc. Okay, next 1 by 1 minus 3x. If you don't know the sequence, then you have to solve it. You can just solve and find out. Okay, but if you study it, it is easy for you to apply. Otherwise, you will have to sit and solve in the exam hall. So 1 by 1 minus 3x. This is the generating function corresponding to the sequence 1, 3, 9, 27 powers 3, 3 raised to 1, 3 raised to 2, 3 raised to 3, etc. Okay, this is corresponding to 3 raised to 0, 3 raised to 1, 3 raised to 2, 3 raised to 3, etc. That is 1 by 1 minus 3x. Okay, then x by 1 minus x is the generating function corresponding to 0, 1, 1, 1. See here for 1, 1, 1, it is 1 by 1 minus x. If the a0th element is 0, then the generating function is x by 1 minus x. If a0 is equal to 1, then the generating function is 1 by 1 minus x. If a0 starts from 1, if a0 is 0 and then the remaining are 1s, then the generating function is x by 1 minus x. Okay. Then the sequence, for the sequence 0, 1, 3, 9. So we said for the sequence 1, 3, 9, it was 1 by 1 minus 3x, isn't it? For the sequence 1, 3, 9, 27, the generating function was 1 by 1 minus 3x. But for the if the sequence starts with 0, that is 0, 1, 3, 9, 27, etc., then the generating function is x by 1 minus 3x. Okay. Then next, for the sequence 1, 2, 3, for the ordinary sequence 1, 2, 3, 4, the generating function is 1 by 1 minus x squared. So this is what we have applied in our last question. If you are asked to find out the sequence corresponding to a generating function, all these, if you know all these formulas, you can compare the question with these formulas and find out to which sequence it matches, and then you can generate the sequence. Okay. So 1 by 1 minus x the whole square is the generating function corresponding to the sequence 1, 2, 3, 4, 5, etc. Is it clear? Did you understand? Do you have any doubts in this section? Do you have any doubt in this section? Anyone who if you have any doubt, just ask. Okay. So just study these formulas, some basic formulas, so that you can apply it and solve questions. Is it clear? Do you have any doubts? Hello? Do you have any doubts? So I had told you how many sequences to study. You can study whichever sequence you want, but these basic sequences you must always remember since you have to solve problems. Okay. So shall I move on to the next section? Okay. Next is the exponential generating function. Okay. Now let us see what this exponential generating function is. You can write it along with me, okay, the notes. So now you can define exponential generating function as follows. For a sequence, for a given sequence, for a sequence A0, A1, A2, etc. of real numbers. Given a sequence of real numbers, the exponential generating function is of the form the exponential. We were now, in the last few examples, we were dealing with ordinary generating functions. Okay. Exponential, just check the spelling. So for a given sequence, A0, A1, A2, etc., the exponential generating function is of the form f of x is equal to A0 plus A1 x by 1 factorial plus A2 x square by 2 factorial plus A3 x cube by 3 factorial plus etc. Okay, so this is the general form of exponential generating function. So earlier we had written another generating function g of x is equal to a0 plus a1x plus a2x square plus etc. Isn't it? You can either write it as g of x, or if you want, you can even write it as f of x. Okay, either you can write it as g of x or f of x. So let me put here f of x. So the earlier questions which we had solved so far, we were dealing with this sequence, isn't it? A0 plus A1x plus A2x square, etc. Isn't it? Instead of f of x, you can give g of x or anything, any function, or you can even give a variable name like abc, etc. So we call this function, this generating function, as an ordinary. This is called an ordinary generating function. Okay, the function which we had dealt with now so far is an ordinary generating function. Okay, and this ordinary generating function is of the form a0 plus a1x plus a2x square, etc. Is it clear? So now let us compare this ordinary with the exponential generating function. I told you the exponential generating function is of the form f of x is equal to the same coefficients are the same, a0 plus a1x is there, a2x square plus a3x cube, etc. But here you have a denominator also, that is x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, etc. So this form of the generating function is called exponential generating function. Okay, is it clear? So we have two types of generating function. One is the ordinary generating function, which we had studied so far. There was no denominator part here. And for the exponential generating function, you have the factorials below each coefficient. Okay, for each term. Is it clear? Is it clear? We have two types of generating function. What are the two types? What are the two kinds of generating function which we have discussed now? What are the two kinds of generating functions? Very good. Ordinary generating function and exponential generating function. What is ordinary generating? What is the general form of ordinary generating function? What is the general form of ordinary generating function? Ordinary. Ordinary generating function, and we have exponential generating function. So what is the general form of ordinary generating function? അതല്ലേ നമ്മൾ ഇത്രയും നേരം ചെയ്തുകൊണ്ടിരുന്ന ജനറേറ്റിംഗ് ഫംഗ്ഷൻ അല്ലേ? ഓർഡിനറി ജനറേറ്റിംഗ് ഫംഗ്ഷൻ ആണ് നമ്മൾ ഇത്ര നേരം എക്സ്പാൻഡ് ചെയ്തുകൊണ്ടിരുന്നത്, ഒരു ഇൻഫിനിറ്റ് പോളിനോമിയൽ എന്ന് പറഞ്ഞിട്ട്. അതിന്റെ ജനറൽ ഫോം എന്തായിരുന്നു? വാട്ട് വാസ് ദി ജനറൽ ഫോം? What was the general form? F of x is equal to a0 plus a1x plus a2x square plus etc. Isn't it? F of x or g of x or any variable in terms of x is equal to a0 plus a1x. This is the ordinary generating function corresponding to the sequence a0, a1, a2, etc. Isn't it? The sequence corresponding here to this ordinary generating function is a0, a1, a2, etc. അതിൽ നമുക്ക് sequence തന്നപ്പോൾ generating function ഒക്കെ കണ്ടുപിടിച്ചു. Generating function തന്നിട്ട് sequence കണ്ടുപിടിച്ചു. So till now we were dealing with ordinary generating function. Isn't it? Is it clear? Any doubts? Any doubt? Hello? So far we were dealing with ordinary generating function, and it is of the form a0 plus a1x plus a2x. So next we are moving on to exponential generating function. What is the general form of exponential generating function? F of x is equal to, it is the same form. ചെറിയ ഡിഫറൻസ് മാത്രമേ ഉള്ളൂ. a0 plus a1x plus a2x square plus a3x cube. It goes like this, but the thing is here you have one more term below, that is x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, etc. Okay, this is again an infinite series. Is it clear? Is it clear? Okay, so here we can write it as in summation form. നേരത്തെ നമ്മൾ summation form എഴുതി general ഇതിന്. ഇവിടെ നമുക്ക് summation formula I is equal to 0 to infinity ai x raised to I by I factorial. ഇവിടെ സമ്മേഷൻ എഴുതുമ്പോൾ സിഗ്മ ഐ ഈസ് ഈക്വൽ ടു 0 to infinity എ ഐ എക്സ് റൈസ് ടു ഐ ഉള്ളൂ. ഇവിടെ വരുമ്പോൾ എക്സ് റൈസ് ടു ഐയുടെ താഴെ ഒരു ഐ ഫാക്ടോറിയലും കൂടെ ഉണ്ട് എക്സ്പൊണൻഷ്യൽ ജനറേറ്റിംഗ് ഫംഗ്ഷൻ. Is it clear? Did you understand the two types of generating functions? രണ്ട് ഡിഫറെന്റ് ഫോംസ്. ഒന്ന് നമുക്ക് എക്സ്പൊണൻഷ്യലുണ്ട്. എക്സ്പൊണൻഷ്യലിന് ഈ ഫാക്ടോറിയൽ വെച്ച് എഴുതുന്നതാണ് എക്സ്പൊണൻഷ്യൽ, ഫാക്ടോറിയൽ ഇല്ലാതെ എഴുതുന്നതാണ് ഓർഡിനറി ജനറേറ്റിംഗ് ഫംഗ്ഷൻ. അല്ലേ? ക്ലിയർ ആയോ? Did you understand? So let us see. An example of exponential generating function. Let us move on to an example of exponential generating function. Hello? Any doubts? Do you have any doubt? So an example of the exponential generating function. Write the heading. Example of exponential generating function. Here we study two examples of exponential generating function. The first one is the Maclaurian series. Maclaurin series. Maclaurin series. Okay, we are going to look at two examples of exponential generating function. One is the Maclaurin series expansion. And this expansion you need in study, it comes from Taylor series. So you just understand that you study the general form of an exponential generating function and then apply it to Maclaurin series. So let us see what Maclaurin series is. Here, e raised to x, it is the expansion. Maclaurin series is the expansion of e raised to x. It is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial. This is similar to the exponential generating function sequence, isn't it? So Maclaurin series is an example of the exponential generating function. Since it is of the form a0 x raised to 0 plus a1 x raised to 1 by 1 factorial plus a2 x raised to 2 by 2 factorial, etc. So this is Maclaurin series is an example of exponential generating function, and let us see how we can use it. So example of exponential generating function is Maclaurin series, and you should write e raised to x. Maclaurin series is e raised to x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial, etc. Okay. Or you can write it in summation form as sigma I is equal to 0 to infinity. This is an infinite series. X raised to I by I factorial. When you expand this, you will get this sequence. Okay. So this, when we look closely at this series, we can consider this e raised to x as e raised to x can be considered as an ordinary generating function. You can convert it to an ordinary generating function when the coefficients or when the series coefficients or series considered is 1, isn't it? If you are taking the series 1, 1, 1 by 2 factorial, 1 by 3 factorial, 1 by 4 factorial, etc. If I'm going to include this 2 as the coefficient of x square, then this becomes an ordinary generating function of the form x is x raised to 0, x raised to 1, x raised to 2, etc. That is the ordinary generating function. So we can consider e raised to x as an ordinary generating function if the coefficients we are considering is 1, 1, 1 by 2 factorial, 1 by 3 factorial, 1 by 4 factorial, etc. But if you are considering it as an exponential generating function, then this 2 factorial should not be considered as a coefficient. It comes with the powers of x, or 3 factorial comes with the power of x raised to 3. So this Maclaurin series, it can be considered as an ordinary generating function if we can take the coefficients as 1, 1, 1 by 2 factorial, etc. But it is an exponential generating function if we are considering the series. If we take the series as 1, 1, 1, etc., then here, if you're taking 1, this is also 1, here also 1, here also we have 1, and if you're taking this together, then we are generating if it is an exponential generating function, then the sequence generated is 1, 1, etc. If it is an ordinary generating function, then the sequence generated is 1, 1, 1 by 2 factorial, 1 by 3 factorial, 1 by 4 factorial, etc. So Maclaurin series, we have both the series embedded in this Maclaurin series. Now, let us consider e raised to minus x. E raised to minus x. What is e raised to x? E raised to x is equal to, as I have written earlier, 1 plus x. Here you have 1 factorial. I didn't write 1 factorial there. Here we have 0 factorial, but 0 factorial is 1. So 1 by 1 is 1. So plus x raised to 1 by 1 factorial, x square by 2 factorial, plus x cube by 3 factorial, etc. This is e raised to x. Then let us consider what e raised to minus x is. Again, this is an exponential generating function. You get, substitute x by minus x in this equation, you get 1 minus x by 1 factorial. Since if you substitute for these powers, the sign will not change. 2 factorial plus all the odd powers. For all the odd powers, the sign will change. Okay. Since minus x the whole cube is minus x cube. Minus x cube by 3 factorial. Then this plus x raised to 4 by 4 factorial plus etc. So this is also an exponential generating function. We are just substituting x by minus x. Now let us see. See, we are going to derive certain sequences which are exponential in nature. That is why I am saying like Maclaurin series is an example of exponential generating function, and it is of the form e raised to x. E raised to minus x is also an exponential generating function, and to get e raised to minus x, just substitute x by minus x. Then let us add these two, e raised to x plus e raised to minus x. What will you get? E raised to x plus e raised to minus x. What will you get? When you add these two series, 1 plus 1, it becomes 2. Then when you add these two, these terms will cancel, isn't it? X by 1 factorial and minus x by 1 factorial will cancel. So here you get plus x square by 2 factorial plus x square by 2 factorial. You get 2 into x square by 2 factorial. Then this odd terms will cancel out and even terms will be twice there. So you add x by 4 factorial, x raised to 4 by 4 factorial plus x raised to 4 by 4 factorial, 2 into x raised to 4 by 4 factorial, and so on. So this, you can take the 2 term outside. This becomes 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. Now I'm bringing this 2 down. You get e raised to x plus e raised to minus x by 2 is equal to 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. So these formulas we have to apply it in certain problems. So that's why I'm writing it down. Okay. So anyway, these are all exponential generating functions. So likewise, similarly, what is e raised to x minus e raised to minus x? Now I found out e raised to x plus e raised to minus x. Now what is e raised to x minus e raised to minus x? What will you get if you subtract these two terms, e raised to x minus e raised to minus x? Here we got the even powers. When you minus it, you get the odd powers. Okay. So write that also. E raised to x minus e raised to minus x is equal to, or you solve it similarly and you get that e raised to x minus e raised to minus x by 2 is equal to x. 1 and 1 will cancel. Then x plus x cube by 3 factorial plus x raised to 5 by 5 factorial, etc. Okay. So these are examples of exponential generating functions. Maclaurin, this is about Maclaurin series and some formulas related to Maclaurin series which can be considered as exponential generating function. Okay, if you are, the question is, what is exponential generating function? You have to write all these examples. Okay. So the next example for exponential generating, this is first example was Maclaurin series. The second example is binomial theorem. We had studied it earlier. Okay, the first example for exponential generating function is Maclaurin series. Second example is binomial theorem. So next class we will take binomial theorem. See why it is an exponential series. Is it clear? Is it clear? So what is exponential generating function and what are the two examples? You have to write both the examples. That is, you have to write the general form of exponential generating function and give example as Maclaurin series. Write e raised to x, e raised to minus x, add the two, subtract the two and write the formulas, and that forms one example. The second example is binomial theorem, binomial series, and that we will discuss in the next class. Okay, so we have two examples under exponential generating function. One is Maclaurin series, the second is binomial series. Okay, is it clear? So, do your attendance?
One.
2.
2.
Okay. 4.
4.
4.
5.
4 present.
6.
Okay.
7. 8.
9.
10.
11. Okay. Next, 12. Absent.
13.
14. Number 14. Absent.
15.
16. Absent. 17. Present.
18.
Okay. Okay.
12 present, ma'am.
19. 20.
Okay. 21. 22. 23.
23.
21%, 22%. Okay.
23.
Okay.
25.
24%. Okay. 25%. Then 26. 26.
27.
27%. 28. Okay. 29. Next 30.
30. 31. 31.
Okay.
32.
Okay.
23.
Okay.
4.
Okay.
35.
35.
36.
36. Okay. 37. Okay.
38.
Next 39%. 40. 40
41.
absent. 42.
43.
Okay. 43%.
44.
Okay.
45.
Okay.
46.
Okay.
47.
Next
48.
49. Yeah, 42%. 49 absent. 50%. 51.
51.
52.
53.
53. 53.
Okay. Okay. 53. 54%. 55.
55.
Okay.
56.
Okay. Okay. 58. Okay.
59.
Okay. 60%. 61%. Like 62 and okay.
62.
63. 63 absent. Okay. 63%. Okay. Absentees. Number 49. Number 40. Then 26. 16. That's all. Okay. Thank you.